So today I'm going to share with this group an updated version of my slide deck. Some of the slides you see today may be very familiar to a lot of you that follow this space, but I promise you that I have spent a lot of time kind of updating this deck so that either I have expanded the session I've talked about or I've updated it. I'm on Twitter. You can follow me on Hoitab, Hoitab, and my DM is also open. My direct message is also open. Please, if you do contact me with questions, give me a little bit of context. Maybe you've seen me at the ML Bootcamp, just so that I can kind of filter out any spam there. So without further ado, let's kind of get into it. Normally, at this stage, I will go into what is machine learning, but I think Khan have done a really good job in terms of outlining what machine learning is and how it's different compared to traditional programming. So dive maybe a little bit into why we're doing it on device. So next slide, yay. So why are we doing this on device when we have the wonderful data center that Google have built or other kind of service provider have built? And for me, it is about three things. The first thing is around privacy. So if the data is processed directly on your device, the data can just stay on your device. So imagine you're using a camera to scan a credit card. You kind of don't want to send the background of how messy, I guess I'm talking about myself, how messy my living room is to your credit card kind of provider. So by processing on device, none of those images are sent and all the processing is done on device. Second, offline. If you have used the London Underground before, then you will understand that not everywhere has a connection or reliable one. So saying on device, you can basically do all the entire user journey could just happen without any connectivity. And third, and my favorite feature of doing this on device is low latency. So there's no round trip between your device to the cloud data center. And as a result, what you can deliver is a live experience where you can give direct feedback to the user that they can react to. And that really enables kind of new types of user experiences, as we may see kind of in a bit. So in today's talk, I'm going to talk about 4 different areas where we have a lot of tooling for developers or program managers or designers. So the first area that I'm going to go through is going to be around design, and I'm going to go to talk a little bit about the different Android platform API that you may find useful. And then I'm going to go to MLKit, which is the Google machine learning turnkey solution. And then finally, I'm going to talk about some TensorFlow tooling that is available to Android developers. So first of all, design. Many of you might have seen the People plus AI guidebook that we have launched at Google I/O 2019. And today I'm going to do a little bit something a little bit different, which is to do a little bit of diving into one of the sections to just give you a flavor of what is available in this guidebook. And the section that I've chosen is user needs and defined success. That's the first one. And I think and what I'm going to highlight is maybe some of the points where when I talk to mobile developers, they find, oh, that's interesting. That's not something that I've encountered before when I'm programming in a non-machine learning kind of world. So the first thing that I would like to say is this is often the kind of question that we get from our managers is like, hey, can we add AI to our app? And what we think is the first step you should do is to maybe take a step back and say, hey, what are the user problems that we're trying to solve? And then we say whether machine learning will help to solve that problem. Quite often people will choose machine learning as I would say inappropriate solution in some circumstances. And sometimes they are not solving the highest priority problems that the users have. In both those cases, we discourage those kind of use of machine learning. And instead, what we want is for all of you to focus on this star area where you can have a solution that have a large user impact as well as really suitable for machine learning dependency or for the machine learning technology. So the next thing that I'm going to go to is a other term that maybe not at all familiar for people that have not been doing a lot of machine learning development. And it is the decision between precision and trade-off in terms of optimizing for what the users is actually, what we actually want to achieve with machine learning. And for that, I'll use an example, a Google app that some of you might have used. This is called Bolo, which is a app that you can download and can teach children to read aloud. So what the app does is you read to the child, and then with on-device machine learning, we will help to determine whether it is right. And if I go back to why are we doing this in on-device, some of the environment where this app is being deployed, the connectivity is not fantastic. So yes, we can stream the child's voice to a data center for detection. So these circumstances, this is simply not possible. So by having the model on device to say, hey, well done, you pronounced this properly, or oh no, maybe try again, we can really enable a lot this kind of experience to a much larger user base. So in this context, what does precision and recall actually mean? So with precision, what we're talking about is bias towards getting less false positives. And in Bolo's case, what this means is more correct pronunciation will be marked as incorrect. So you might say something that's correct, and the app will go, well, I'm not sure, please try again. So that's optimizing for precision. The other one is optimizing for recall, which is to capture a little bit more false positive, but be a little bit more lenient. And in Bolo's case, we'll mark more incorrect pronunciation to be correct. So in this case, what do we choose? The team actually choose recall, a high recall. And to understand this decision, we need to put ourselves into the children's shoes. So when you're starting to learn a language, you really want to encourage the children to try more. And as a result, you might want to mark them as correct, even though that they may be a little bit wrong. So if a human is doing that, why not machine learning? So we're purely kind of encoding that kind of encouragement into machine learning. So this is why the team optimized for high recall in this particular instance. So next, and last that I want to highlight in design is automation. So quite often when developers, mobile developers thinking about machine learning for the first time, they are thinking about automation. Hey, how do we completely take in the human out of this and just put the machine in and replace the human? And quite often we encourage the developer to think about a second concept, which is what we call augmentation. So instead of replacing the human, think about how you can help human users to achieve their task better. So think of, put yourselves into the position of being a bank, and you have a need to capture a certain letter or a proof of identity. And what you want to do there is to say, hey, is the picture actually focused? Can you actually read what the user is taking a picture of, in terms of the letter or the identification document that they have scanned? And with on-device machine learning, we can really help you to do that. And what this means is you can enhance the user experience that you have today and basically help your user to perform certain tasks better. And again, going back to why we're doing this on device, one of this is low latency. So you don't need to send every frame to your cloud data center to say, oh, that image is not focused. But instead, just give the user immediate feedback and say, hey, this image is not focused. Can you try doing this and that? Or maybe more light, less light. Hey, I can't read the letter, or oh, I don't see the entire letter. All these can be done with on-device machine learning. So that's design. Next, Android platform. And I will have a little demo. So let me just unlock my phone. Yay, okay. Let's hope this works, fingers crossed. Great, so here I have a little demo app for speech recognition. So give it a go. I'm speaking English in London. So you can see that it dictates it correctly. Let's see if it reads it back properly.
I'm speaking English in London.
So this is through a bunch of Android APIs. And some of you might have seen this demo before. And I always say that, hey, English is just table stake now for speech recognition. Why don't we try something a little bit harder? So I'm going to try it in my native Cantonese. I'm from Hong Kong. 我係一個識講廣東-我係一個識講廣東話嘅香港人。
我係一個識講廣東話嘅香港人。
So what this means is I'm a Hong Konger that knows how to speak Cantonese. And for those of you that understand Chinese, you will see that some of the words that I use, like the second character, hai, or the fourth character from the end, ge, those are very typical kind of Cantonese kind of words that do not actually appear in normal Chinese. So this is fully customized for Cantonese use, not just kind of other dialects of Chinese like Mandarin. So if I go back to the slide, some of you may ask, hey, you're using a Google Pixel 3, which API level do I need to use this? When I've asked this question previously in at conferences, 50% of the developers would say, hey, it's nougat or newer. 99% of you would say, hey, it's ice cream sandwich or newer. Actually, the answer is a lot older than that. So the API for text-to-speech is from API level 4, and that's 10 years ago. And for speech recognizer is actually API level 8 from Android Folio. So let me just get the cursor out of the way. And if you want to kind of find out more about how to implement this, I've actually talked about it at last year's Google I/O at the What's New in Android Machine Learning last year, so go and check it out. But one thing that I do want to highlight is that in speaking intent, you can put in the exact language that you want. And I know that for today's audience, a lot of you do not have English as a native language. So here I just want to really highlight this option so that you can try this out for your particular language. And given that Cantonese, which is spoken by about 7 million people in Hong Kong, is supported, we do have a very wide range of language support here. So please do try it out. Next, camera. So a lot of things that both Wei and Khan have shown you is related to kind of image import. So a lot of you would be interacting with the camera APIs when you are dealing with machine learning. And one of the first thing that you'll hit is something like this. Oh, you just download a sample, and in the code it would say a little bit of warning. This camera API has been deprecated. So what I'm showing on screen here is Camera 1 API, which has been deprecated since API level 21. And Camera 2 is the latest API that you should use, but it is very hard to use. I actually tried it myself, and the sample for Camera 2 is 1,000 lines of code. In addition, you also need to deal with a lot of a variety of devices, because Android have a lot of choices in hardware. And as a result, as a developer, you need to deal with a large variety of hardware in the user's hand. So what do? So last year at Google I/O, we introduced CameraX, the Android Jetpack library, and it's really built with 3 things in mind. The first thing, and the most important thing for me, is the ease of use. It's so easy to use, just like Camera 1. Second is focus on device compatibility. and it supports a wide range of devices and a lot of common codes as I'll run you through. And it supports 3 types of use cases: preview, image capture, and image analysis. And given today is the machine learning bootcamp, I'll focus on the last one, image analysis. So first, import. The first thing you will notice is that we're now in beta 3. So what this means in Jetpack land is that this is now ready for production and APIs are frozen. And there are 3 steps for you to get image analysis working. The first step is to create the image analysis use case. And I just want to highlight that you can specify a target resolution. Although something to note is that what the CameraX API will choose is basically the closest one possible. It is not a it may not be exact resolution that you'll get. So if you need to resize the image before you run your machine learning model, you still need to keep that step. The second one that I want to highlight, and this is really hard to do before CameraX kind of comes along, is that you can have different strategy in image analysis. So you can analyze every single frame, or let's say, you got frame number 0, you run your process, and then in the meantime, maybe like 100 milliseconds has passed. And now and you don't want to kind of analyze frame number 1, number 2, number 3, number 4, but just the latest ones, so let's say frame number 10. With this, you could just say, hey, just give me the latest ones, skip over the ones that I was doing processing on, and just send me the latest one, and to keep essentially your image processing pipeline smooth. This is now super easy to do. You could just say image analysis strategy, keep only latest. So after you've defined your analysis use case, you then set your analyzer. And 2 things to highlight here. One is this is where you should put your machine learning code. And because we use strategy keep only latest, it's really important for you to close out the images after your analysis so that the next frame will be sent to your analyzer. I often make this mistake of missing those and then just go, oh, the CameraX routine only run this once and it didn't run it for the second time. What happened? And it's because I didn't close the image properly. So just be super careful with this one. Otherwise, your analysis will run once and you wouldn't get a second frame. And after you have defined your analyzer, you just go ahead and attach it to the lifecycle, and it's done. So what else is new? All these are beta APIs that have changed since Google I/O last year. So what else? The second thing that I want to go through is the preview view. So quite a lot of you will have a preview in your app because you want the user to be able to see what they're pointing at. And to make it super easy, we've now created a new view component called preview view. And the first thing that you'll notice is that it is unfortunately in alpha. So some of the APIs that I talk about today will change. But as you see, it is a super powerful kind of set of APIs. The first thing is really easy to use. So to put it into your view, all you need is this. You just say, hey, I just want the preview view, and I just want to fit it to the entire screen, and you're done. So 4 lines of XML. Then after that, you will need about 10 lines in your initiation code to be able to implement it properly. But that's all really well covered by the documentation. So I'll skip over those, but instead I'll cover this. So a lot of you might want to implement something a little bit more advanced, like camera zoom. And this is really hard to do in camera land. But with CameraX and the preview view, you can now do it really easily. And all you need to do is to have this code, and I wouldn't kind of go through and explain it, but this is the end result that you will see. So you could just pinch and zoom, super easy. Just go back to the code, just these couple of lines of code, and now you have pinch and zoom in your preview. Super easy. So to find out more about CameraX, go to g.co/CameraX. Next, so that was the Android platform. Next is MLKit. So MLKit is Google's machine learning library. It works like any SDK. There is no machine learning expertise required. It is built on TensorFlow, on top of TensorFlow, and it supports both Android as well as iOS. Back in 2018, we launched with these APIs. And last year, we added natural language. And one of those I want to highlight is Smart Replies. So with Smart Reply, you could just give us a string like, hey, should I take that job at Google? And it will give you a reasonable reply with no, sure, yeah. And you might say, hey, this is relatively simple. What else are you giving me? Something like this. So when the user is asking for or discussing something sensitive, it could be politics, it could be religion, it could be other kind of contentious issue, then the algorithm is designed to back off and not give you any reply at all. So something to be aware of when you're kind of using a machine learning model that is from MLKit versus the raw model that you might be able to find on TF Hub or the internet. Next thing that we did was to launch more APIs. So we have object detection and tracking, on-device translation, material design, as well as AutoML Vision Edge. So with translation, we support 59 different languages. It is completely free for the on-device version for developers, and everything is run on device, so the conversation are not sent to Google at all. So you could be assured of the user's privacy on that count. And next is object detection and tracking. So here you basically point at a particular image, and the API is able to pick out the different objects and help you with your machine learning task. So how does it work? So the first thing you do is sends the camera stream to the MLKit API. We call it ODT, standing for object detection and tracking. And then next, what we also do on device through MLKit is you can optionally classify them or filter them using different classifications from home goods to places. And in this particular example, we actually send it over to Google Cloud to do a visual search, and it comes back with, hey, what are the different products that looks like that, and then also maybe other information like inventory. And since today we are talking about on-device machine learning, another way that you can implement this is this. So instead of sending the image to the cloud, you can also have a on-device model that runs and classify the object on the device itself. So what are the different trade-offs? For some use cases, such as diagnostic of plant diseases, it may be appropriate to have the model on device because, you know, in rural areas, in whatever country, you know, you might have a low connectivity kind of bandwidth, etc. So it may be really good. It may be really suitable to basically have the model on device. On the other hand, if you are dealing with shopping, for example, you need to connect to your data center for inventory kind of data anyway. And in addition, your inventory kind of changes all the time. So it may be more appropriate in those cases to use the cloud solution so that you can keep those things updated. And kind of coming back to the on-device scenario, one thing that we do support is AutoML Vision Edge, but I'm not going to talk about it. Please pay attention to the next session where Kaz will take you through in detail how to use AutoML Vision Edge. So the last thing that I want to highlight on MLKit is there are MLKit showcase apps on GitHub. So you can go to those and download, and they follow the material design guideline for machine learning. And the source code is available. And this is where a lot of developers have told me that it's super helpful for them, because all they need to do is to copy and paste. There is no need to come up with a new user interface at all. Just go ahead and download the code. To find out more, there's another short link, g.co/mlkit. Okay, last topic, TensorFlow Lite. So what I want to begin with is a little story. So back in 2018, that was the first time when I actually tried to create my own machine learning model, following through the classifier Colab that Wei have demonstrated, and created a demo app called Hoi Lam at Dragon Berlin 2018. And the journey has not been smooth at all. When I first try to program this, I get all kinds of different errors when I try to run it. It's like, hey, this file is compressed, the dimension is not correct, and the data type is not correct. And a lot of this, when you dive in, it comes back to a problem that we have. So when you're using TensorFlow Lite, you will need basically an input, and you accept an output. But if you look at the model, this is what you find. Say is an unsigned int, and it is of these kind of dimension. And when you're in Android, what you need to do is you need to turn what you have in terms of structured objects like bitmap, string into byte array before you can run in the TensorFlow interpreter. So, and this is what the code looked like. And we asked ourselves, hey, can we do better? Yes, we can. So I got together with an engineer from the TensorFlow team, Liu Wang, and we say, hey, what if we do something slightly different? What if we put a little bit more information into the TF Lite file that describes what it actually is, instead of just the tensor dimension? And what if the Android Studio have an import wizard for a TF Lite model, and it generates sample code that you can copy and paste? So what actually happened after that? The TensorFlow team and the Android developer team got together, and we got a bigger team. So we have a team that spans London and Mountain View in California, USA, and also Beijing in China. And what did we create? The first thing is some of the models have already been upgraded in terms of having metadata. So if today you go to TensorFlow Hub, please do read the description. And for some of the model that is under TensorFlow Lite, it would say that, hey, this model contains TF Lite metadata, which is a rich description that both human and machine can read. Download those models if you want to use this kind of tooling. And second, Android Studio 4.1 Canary 10, which is coming soon. Actually, this functionality is already working in Canary 9, but today I will demonstrate the more finalized kind of API and the smoother kind of use flow. But Canary 10, which is coming soon, is what I'm showing today on the screen. So the first thing you do is you go to File, New, Other, and then you select TensorFlow Lite model. And you then click on the little button to choose your TF Lite model. So in this case, I'm choosing the efficient net model, and it will copy the model over to your project. In addition, it will add all the Gradle.build settings that you need. And then you will see the screen, which is it opens up the model. It tells you what the model is about. It even shows you the license. So for the people that is worried about, hey, can I actually use this model? You can click into it and or kind of forward it to your lawyer. In addition, the bit down at the bottom is really important. So this is the sample code that you need. Just 4 lines of code. I'm excluding the try catch here. But this is all the code that you need to run the model itself. So let's compare this to the previous stage. So previously we have this amount of code, and now we have this. So this tooling is available from, actually, I think from Canary 8, I would say. But the flow that I've demonstrated today is Canary 10 and is coming soon. You can download that at d.android.com/studio/build, and we would really love for you to comment on the APIs that we have, so we can refine it, or any user problem that you find. So give us feedback. So just to summarize the 4 things I've talked about: the first thing in design, the People Plus AI guidebook. Second, on the Android platform, the voice-related APIs, as well as CameraX APIs. Third, ML-Kit, the turnkey solutions that you can find, really powerful APIs like Translate and object detection and tracking. And finally, TF Lite, the new import wizard that is coming very soon. To find out more, here's a link with all the Android tooling that we have, is d.android.com/ml. And with that, thank you very much.